Hello everybody, this is Rudra Pradhan here. Welcome to Engineering Econometrics. Today we will continue with nonlinear regression modeling, and that too the extension of dummy modeling. So, let us see here what are the contents we like to discuss in this lecture. So, basically we have discussed the concept of dummy modeling, that too while discussing the interactive effect and the kind of structural problems where there is a need of introducing a dummy variable. And in fact, the utility of this modeling is very high, and most of the engineering problems it has high relevance. So, in these lectures, so we will briefly discuss this, and then we can extend to the little bit higher version. Whatever we have discussed, that is the basic approach about the dummy modeling, and the idea is that while doing the regression modeling, the requirement is you must have a dependent variable and you must have independent variable. If not dummy modeling, then the dependent variable and independent variable both will be numeric in nature. That means, the variables information which you call as data, which must be numeric in nature. However, in real life scenario, couple of engineering problems where some of the variables cannot be quantified properly. That means, we may not have a numeric representation. That means, the data or the information to the particular variable is not actually quantitative. So, that means, technically there is a structure or there is a information about qualitative variable. So, qualitative variable means the information is qualitative in nature. For instance, what we have discussed earlier is the kind of gender impact, or the guy married, unmarried, or the kind of religion impact, or the kind of stability, instability impact. So, like there are various ways you can actually use the dummy variables, where the components or the kind of information will be qualitative in nature. So, now technically if you go to dummy modeling, so let us say this is a brief framework about the dummy modeling. The dummy modeling, in other words, it is called as a qualitative response regression modeling. So, it can have two different structure. One is the dummy dependent modeling and dummy independent modeling. So, which this part we have slightly discussed earlier. So, what we will do? We just briefly touch upon this particular component, then we will discuss this part, which is not actually discussed yet. In the dummy independent modeling, where one or few of the independent variables will be qualitative in nature, while dependent variable is quantitative in nature. So, that means, the information content is actually numeric in nature in the context of dependent variable. However, the information may numeric or may be qualitative in the context of independent variable. Since it is a dummy modeling and that to dummy independent modeling, at least one independent variable must be qualitative in nature. That is the requirement. So, as a result, this kind of modeling is a very special character or special type of models, and it cannot be applied each and every scenario. Like simple regression modeling, you can apply any kind of engineering problem, provided you must have a dependent variable, you must have an independent variable, and theoretically you may expect that there is a kind of relationship, or logically you can establish that there is a kind of relationship. Now, what in the kind of dummy modeling will tell you that so you have to specify or you have to apply a particular situation where at least one dependent variable will be qualitative in nature, and that will be one of the important variable which can predict the dependent variables. That is what the kind of the structure which we can have in the analysis. So, in the other sides we have a dummy dependent modeling, which we have a 3 different forms altogether, and that is the kind of say linear probability model. Then we have a logit model and we have probit model. So, that means technically in the domain dependent modeling we have a 3 different models which means which are very beautiful and applied in a situation where dependent variable is actually qualitative in nature. So, your independent variables may not qualitative, but the minimum requirement is that dependent variable must be qualitative in nature. So, first we touch upon the dummy independent modeling, that means which we have already discussed, but we will just once again target, then we will come upon the kind of dummy dependent modeling. So, let us see how is this particular game. So, what we will do here, I will just briefing the idea about the dummy modeling. So, dummy modeling means it is a nature of the qualitative information, and then we will discuss how dummy variable can be used. Then there are a speciality in the dummy modeling, and then dummy modeling with multiple categories. The problem which we have discussed till now is related to only yes not kind of situations like male females, then married unmarried, divorced not divorced. This means only in a bivariate framework only, but there are instances where dummy can be used in a multiple categories. So, same variables can have a different kind of scenarios. For instance, cited example may be religion. So, where 3-4 types of religion may be there, or sometimes you are trying to study the seasonality, there may be 4-5 seasons you can take, or you can try to impart monthly impact on the relationship between dependent and independent variable. So, in that case you may have a different kind of dummy representation. So, that means if monthly impart, then so at least 12 dummies can be introduced in the system, and for that your data size should be very substantially very high. If you are increasing more number of dummies, and by the way the size of the data is very small, then you may not in a position to address the problem, because most of the variables may not be statistically significant, which may affect the reliability, and as a result you cannot use this model for the prediction and forecasting. Then some of the instances you can use for the structural stability. So, the nature of qualitative information which we have already discussed. The cited example means base cited example is the gender impact on the salary structure, then religion impact on the consumption pattern, educational levels in earnings, or the kind of employment structure. So, I mean these are all various types examples, or various scenarios where the use of dummy modeling is very frequent in fact. And then we will have here some of the more such kind of scenarios. Changes in political regime may affect the production process, and the war impact on economic activities. So, war means the war happening in a particular year and not happening. So, this is the kind of situation you can study. Then crisis impact, then the kind of seasonality impact again. So, these are all various types of kind of problems where dummy can be frequently used. So, that means once you know the kind of structures, so you can specifically use this dummy modeling, and it is as usual actually regression modeling. Only thing is the variable understanding will be little bit different, and that too it should be classified in 2 different groups or 3 different groups something like that. And to understand more in a much better way, so we may have a equation like this. Okay. So, this is a equation where we have x 2 and this x 2 maybe means it is only one variable. So, by default it will be dummy if it is a dummy modeling concept. Then let us say it is a gender import. So, it will be male female and then the transformation will be 0 1 and y is the salary structure, which we have actually discussed last couple of lectures. So, that means that is very easy to understand the dummy, and you can actually easily you can study the import. That means technically there are various factors which can affect the salary structure, but even there is independent variables, then still gender can be created and we can study the gender impact on the salary. So, that means that is a very beautiful component through which you can model can extend as per the particular requirement. So, it brings some kind of consistency or stability to analyze the problem. Then you will have actually different kind of structure altogether, that is what the description. So, these generally varies from 1 to 0. So, 1 for male and 0 for female. So, as a result, once you get the estimated output, so in one case y equal to alpha only, and another case y equal to alpha beta, alpha plus beta, where the representation is the male, and when beta equal to 0, then the representation will be female, and in that case y estimate will be only alpha. So, and if you add beta, then that will go to the male side. So, that is the kind of difference. So, you see here. So, the model will be like this. So, in this case we have one independent variables and one dummy variables, both are independent, but this is numeric in nature. So, in this case, so this may be numeric in nature and this side this is a dummy in nature. So, now if you put d equal to 0, then the model will be restrict to this much, and when d equal to 1, then the model will be restricted to beta 1 plus beta 3 plus beta 2 x 2. So, beta 2 x 2 will be common both the sides, only thing is the extra component will be beta 3 will be added, that will be discriminated into two different groups. That is the kind of examples which you can have in the case of dummy modeling. Okay. So, this is how the various clusters where we can differentiate the two different categories. So, this is a kind of example which you like to discuss. This is a case study and it is a civil engineering problems, thus two real estate problems. Usually for the builders or the kind of consumers, they are very keen to know what should be the housing price and what are the factors responsible for that. And by using this case, you can get to know how dummy modeling can give some kind of better structure to predict the housing price, because the usually or theoretically a house flat price will vary from various factors with respect to number of rooms and with respect to distance, with respect to facilities, with respect to quality. So, so many items are there which can affect, and dummy modeling is a very beautiful concept where we can actually use and very easily capture all these factors and then predict the housing price as per the builders requirements and as per the customers requirement. So, before we start this particular case, so let me give you as examples as data set, how does it look actually in the dummy modeling case. So, let us say so this is a kind of an example, we will just discuss same case differently. So, now in this case, so we have actually 31 samples. So, this is the 31 sample, and then we have the housing price. Okay. So, let me maybe these are all in lakhs, and then it is a different factors which can responsible for that, size of the house, then elevation, sewers, depth, flood, distance, what I have already mentioned. You see here. So, this price is the dependent variable, and then these variables are actually independent variables. So, now in this problem, so we have a dependent variables like this, then dependent variables like this, and then the the dependent variable like this. So, that means technically, so the entire set is actually dependent variables, where we have altogether 7 independent variables, and out of which the first independent variable and sixth independent variables, they are dummy in character. So, that means this is actually county yes no situation. So, where yes it is 1 and where no 0. Similarly, whether flood can affect the housing price. So, in that case, so if flood is happened during that locality, then it will be 1, if not it will be 0. So, that means it is a pool of data from different locations, and then we are trying to predict the actually the housing price. After these are all called as sample structuring. So, once you do the sample structuring, then the estimation process will be as usual very same. For instance, after having this spreadsheet, that obviously you have to understand these variables, you have to also understand this variable, how the impact can go to the housing price, and ultimately you go to the data analysis, and as usual allow the software to run the regression. So, this is what the regression tool, and now just indicate the housing price years up to this 31 samples, and then you have independent variables, and you include all the independent variables simultaneously, starting with county to distance, and where we have couple of dummy variables and couple of quantitative independent variables. Then you just put OK. You will find these results. You see this very interesting results, and R square is very high, and adjusted R square is also very high. F is statistically significant, and these are all the variables coefficients starting with the county to distance, and then these are the coefficients. Some are having negatively related, some are positively related, and what is more important that these are all t statistics behind these variables, and most of the instances the variables are statistically significant. Variables are statistically significant, that means there is a impact. So, and that too all these variables are significantly influencing the housing price. So, now after knowing this, so now what is the more important is how you actually plan or structure the models for the customer attractions, because usually most of the instances a customer will attract your product. Here the product is the house, and if you have a different kind of variety, of course price will be high depending upon the variety, but the beauty of the dummy modeling that it by default will give you lots of flexibility or diversity for the customers attractions, and that itself will brings big business to the builders and the kind of real estate problem. In this context, I'll just discuss this particular case, and here you see here what will you do. We have two sets of variables. So, that means technically this case is like this, where y is the dependent variables, where we have let us say alpha is the constant plus summations beta I x I equal to 1 to k, then plus summation delta j dj, delta j dj, delta j dj plus u. So, j equal to let us say 1 to m. So, that means this is x. So, this may be x 1, x 2, x 3 and so on, and this dj it may be d 1, d 2 and d 3. So, that means all are independent variables, and this particular cluster is the dummy independent independent variables, which is numeric in nature, but this dummy is actually this variable is dummy independent. So, that means this variable represents qualitative information and this variable represents quantitative information. So, as a result, so we like to check how these independent variables affect the dependent variable and how these dummy variables affect the dependent variables. So, now this is the model which we have applied in this particular case to understand the price variations, and that to how beauty the dummy modeling is. and to represent the housing price with different features and different character. So, now altogether, so here j equal to 1 to a means number of dummies. So, now we have taken 4 dummies here d 1, d 2, d 3, d 4 and d 5. The expert will incorporate after this. So, now first one is the d 1, that is the first dummy, and which represents 1 and 0. If 1, then represents house as a driveway, and if d 1 equal to 0, so the house has no driveway. So, that means technically any feature is yes means it will add to the housing price. So, that by default the housing price will be up, that is basically add-ons. All these add-ons will be yes no kind of situations, and by default it will add value to the housing price. So, if you reduce the add-ons, then by default housing price will be reduced, and d 2 is equal to 1 if the house has recreation facility, and 0 if that is not there. Similarly, d 3 is a dummy variables which represents 1 if the house has a basement, and 0 if not. Similarly, d 4 is another dummy variable which represents house has a central heating facility, and d 4 equal to 0 if the central heating facility is not there. Then finally, d 5 if the house has AC facility, then d 5 equal to 1, and once d 5 equal to 0, that means there is no AC facility. So, that means technically if all the facilities are there, so that means d 1 equal to 1, d 2 equal to 1, d 3 equal to 1, d 4 equal to 1 and d 5 equal to 1, and that means 5 different impact will go to the intercept, and as a result the housing price will go up. Okay. So, that is the kind of things which you can have to predict the housing price with respect to different features. So, let me explain how we can go ahead with the interpretation, and for that we have already estimated this output. Let us start with first dummy, and where the model starts with the y equal to alpha plus beta d, and that is the error terms. Then we will go ahead with the estimation process, and then finally we will have estimated model y cap equal to alpha cap plus beta hat d. So, now we have two options. So, if d equal to 1, then the y cap equal to alpha cap plus beta cap. If d equal to 0, then we simply have y cap equal to alpha hat. So, that is the kind of difference. So, we have two different options only. So, first option and second option. So, that means when you apply different dummies, so we have a plenty of options by default, right. So, now what we can do. So, let us assume that alpha hat equal to 59,000 approximately, and beta hat equal to 25,996. Then housing price will be having, let us say, dummy is AC facility. So, now what is the house price with AC facility? So, in that case, so the value will be alpha plus beta, that is 85,881, and if there is no AC facility, then y cap is simply alpha hat. In that case, the housing price will be simply 59,885, and if AC facility is there, so 25,996 will be extra. So, that means technically introducing dummy by default give two different package, where we have one situation AC facility, another situation not AC facility. Where if you require AC facility, then the housing price will be 85,881, and if not, then the housing pricing will be 59,885. So, likewise you can have another dummy also. So, now in this case, so what will you do? So, you allow with two dummies. So, let us say beta 1 d 1 and beta 2 d 2, and likewise you can extend up to k number of dummies, or in these problems we have 5 different dummies, then you can extend one by one. So, that means technically, So, if there are two dummies in a particular models, let us say like this, you know, see it is a case like this. So, here what we can do, so y equal to alpha plus beta 1 d 1 and plus beta 2 d 2. Okay. So, this will be 1 0 and this will be 1 0. So, ultimately alpha is the common, then in one case alpha plus beta 1 plus beta 2, that is the maximum housing price, and then another model will be alpha plus beta 1 and third one is will be alpha plus beta 2 and then the final one will be alpha plus beta 1 plus beta 2 and then fourth one is y simply alpha. So, in this case. Okay. So, as a result we have 4 different package. If you have 2 different features, so we can bring 4 different price altogether. So, that means technically we have a different options altogether to represent the situation. So, likewise, so let us say this is actually having d 1 and d 2. So, let us assume that this is the estimated output, and by the way the variables are statistically significant. So, by default, so if both the facilities are there, then the housing price will be alpha plus beta 1 plus beta 2. So, as a result, so technically you will have this much of price, and if both the facilities are not there, then the housing price will be this much only. If only one facility is there, let us say this one, then the housing price will be this much, and if this facility is only there, then the housing price will be this plus this. Okay. So, by default, so we have a 4 different package. So, with all facilities this is the price, with no facility this is the price, with one facility this is the price, and with another features only, so that is the price. So, that means 4 different price pack you will have to attract the customers, and that too it is very easy to predict the such kind of situations by using dummy variables. Okay. So, this is the case here. Okay. So, 4 different cases which you have highlighted. Now, likewise you can actually extend one after another dummy. So, in this case we have actually 5 dummies. So, we can have actually 5 different situations, and then you can have a different price pack as per the availability of particular features, and that too where dummy equal to 1 and dummy equal to 0. So, now we will have a different kind of structure where we can go with the dummy with one more independent variable which is actually numeric in nature. For instance, y is by default here we are discussing about the housing price, and d is the dummy variables. Let us say first dummy AC facility, and x is the another independent variable which is numeric in nature, that means quantitative stock variable. So, here the x represents the lot size. So, if you book the house in a lot, then you can have high and low price or some kind of discounting, something like that. So, that means technically booking the house in a lot, so may have less price if you go by individual purchasing. So, as a result lot size can say affect the housing price in total. So, in this case, so we have actually 4 different package again. So, one package will be alpha plus beta 2 x after the estimations, and then another one will be alpha plus beta 1 and beta 2 x. That's the 2 different, because only one dummy is there. So, 2 different proxies. So, let us say alpha is this much, beta is this much, beta 1 is this much, and beta 2 is 5.64. So, ultimately, so the estimation process will be like this. So, which we can analyze in this case where the dummy can be represented as a 1, then this model will be restrict to this much. Okay. And in this case where dummy equal to 0, then we have the situation like this. Okay. We have the situation like this. So, 2 different regression lines depending upon whether the house has an air conditioning or not. Again, the lot size will also get affected. So, depending upon the lot size, so the housing price will get affected, right. So, this is how the kind of structures which you can have in the help of dummy modeling. So, that means while addressing the or predicting the housing price. So, what is more important is that you have to find out to various variables which can affect the housing price, both both you can say quantitative variables and qualitative variables, and then you can predict as per the particular requirements. So, in this case we have a little bit extension. So, two dummies, one is dummy for driveway, another dummy is having a recreation facility, and as a result. So, if all dummies will be yes, then the model will be alpha beta 1 plus beta 2, then beta 3 x 1 beta 4 x 2, where x 1 is the lot size and x 2 is the number of bedrooms. So, that means when you have more number of bedrooms, the price spec will be high, when less number of bedrooms, the price spec will be low. So, likewise we have a different price spec which can represent the housing price. So, likewise, so if it is d equal to d 1 equal to 1 and d 2 equal to 1. So, this is the price specs, and if d 1 equal to 0 and d 2 equal to 1, then this another price spec, and d 1 equal to 1, d 2 equal to 0, then another price specs, and both will be 0, then there will be another price spec. So, that means by using different dummies, so we have a different price spec, and that is how the beauty of this particular technique to give little bit flexibility or kind of diversity while predicting the housing price, and that too for attracting the builders or the kind of customers. So, that at the end you can get to know that the dummy modeling is a one kind of beautiful structure through which different kind of engineering problems can be analyzed, mostly very useful for this civil engineering problems, and similarly other engineering problems can be used. For instance, a product with different chemical features, and when you have a different colors, then you can use different kind of dummy and can fix the price as per the particular requirement. So, likewise you have to bring a particular problem, and then you check whether dummy variable can be used to analyze this situations, and as per the kind of engineering requirement, and that too as per the management decision is concerned. So, in these lectures we have specifically highlighted the dummy modeling, that to the structure of dummy independent modeling, and by the way we have already discussed couple of problems related to dummy independent modeling, and now we like to see the other side of the games, where the dependent variable is the dummy types. In that case, we have three different models altogether: linear probability models, logit models, and probit model, which we discuss in detail in the next class. With this, we will stop here. Thank you very much.